Thank you very much for coming to this session about testing. How are you? Good? Tired of 3 days of this great conference? Okay, let's talk about testing. My name is Alex Soto. I work in Red Hat. I'm the curator a lot of thejars.com. I contribute with several magazines. And first of all, the important thing is that there is a raffle. I'm the author of Testing Java Microservices, so if you follow me on Twitter with a picture of the session, mentioning me, and with the hashtag DevOpsBCN19, then we have 5 ebooks of Testing Java Microservices, so I will send you the code so you can download it, or if not, you can always just take, let me find if it works or not. OK, it does not work, it doesn't matter. This code, the CTV DevOps BCN19, and you have a 40% discount, not just my book, but any book from Manning. So if there is any question, just raise your hand, and I will try to answer it on when you have it, instead of waiting to the end. And, well, when I did this talk several times, and always there are some people at the end that approach me and says, what you said is a stupid thing, or it's impossible, it has no sense. It's normal, OK, and probably you will think about it as all these guys. But just remember that when you are going to start doing microservices, or microservices architecture, and I mean, when I said microservices, I mean real microservices, when you have 100 microservices, 150 microservices, then it's when you will start finding this talk really useful. So, anyone knows who is this guy? Nobody? Who? Walt Disney. Exactly. This guy is Walt Disney. And why am I introducing here Walt Disney? Well, because Walt Disney created a technique for innovate any process. And basically, what it creates is a technique which you have a process, and this process have several rules. And then what Walt Disney said is like, OK, just pick one rule and ask yourself, what if I remove this rule and I think about replacing with a breakthrough idea? And the first time that was used this was in 1940. And basically, Walt Disney started thinking about, OK, when people go to a movie theater, there are some rules. You cannot move from chair to chair in the middle of the movie, or you cannot control the environment of the movie theater. So every theater is different. And then he thought himself, what if I remove I cannot control the environment, and I can control the environment? But this is not a really breakthrough idea. So he decided to say, what if all the attendees are part of the movie? They are inside of the movie. Remember that this is 1940. There were no 3D or holograms. And thanks to this idea, he decided that it was time to create Disneyland. So now you know where and how Disneyland was created. But you would say, OK, but you're talking me about 40s of the past century. But think about Netflix. Do you know why Netflix is Netflix? Because some guys decided that, ask himself, what if there were no cars? Right? If there is no cars, we need to find a way to send the movies inside each house. And this is why Netflix is what it's today. So remember this, because this will be really important concept during the talk. Since we are at DevOps conference, I suggest you that you check as much as you can these resources, which is from Puppet, which is the State of DevOps report. Every year they release a new version, which you can see the state of the DevOps in several companies. And basically, one of the key concepts is that high-performing organizations are decisively outperforming the lower performance peers. And what that means? Basically, it means that companies that are following DevOps, they are doing 46 more deployments than those that are not doing DevOps. And think about this. This means that these companies are hitting the market 46 more times than his competitors. But it's not only that. They are having 440 shorter lead time. Lead time is the time between you have an idea, you discuss it, you design it, you implement it, and you put it on production. All this time, it's late time. So companies with DevOps, they are going to production 440 times more. And this is a great advantage, right? Because it means that you can have an idea, put it on production really fast, check if it works, and if it works, leave it there, and if not, just remove it from production. But of course, things can go wrong, and companies that are using DevOps are 96 less time to recover from an error. At the end, the errors are there, they can happen, so it's really easy to recover as fast as possible. And basically, this is what's happening nowadays. Not all companies, but some of them, right? This is basically that the developers are not responsible of what's happening with their software. They just go to Jira, they took up an issue, they read the description, implements, they just write a test, or not. They push, they wait until Jenkins shows the blue or green bullet, and that's all. They don't care about what's happening with this software. And then, well, probably people from Ops will spend their weekend trying to deploy all this new application, following some wiki page, which probably is updated. So the thing is that we need to all Dev and Ops work hand by hand. If Ops stay all the weekend on the office, Devs are on the office as well. But of course, this means that we need to change the definition of done. And this means that your code has no value until it's deployed on production. So this is one of the first things that you need to do in your organization if you want to embrace DevOps. It's like one thing is done when it's in production. Until it's not on production, it's not done, and it means that all the team should be there supporting it. And you can think about that. Me as a developer, most of the time we are spending all our efforts on discussing if this should be done with this framework, with this other framework, with this language or other language, or apply patterns or not apply patterns, and so on and so forth. But just think about this. It doesn't matter if you apply patterns or not if your code is not on production. But a lot of companies, they say, yeah, I have a DevOps department. We have Dev and Ops working together, but we are not able to release pretty often. And the reason is that, because it's not about Dev and Ops, it's about all the organization. All of them should have a common ground, which is getting a goal. And you can see that it's implied Ops, PMO, BSec, Dev, DBA, and QA. And please check here DBA. I'm not saying that DBAs are zombies. Yeah. I'm saying that DBAs loves Walking Dead, just in case there are some DBA on the room. So you can start doing CI/CD, continuous improvement, you build your application all the time, you test it continuously, you have continuous integration and testing. Then when you have this mature, you said, okay, maybe now it's time to try continuous delivery and continuous deployment. You start releasing and deploying constantly. And then when you are into continuous deployment, you start doing continuous operation, which basically means you are monitoring all the time your applications, inspecting what's happening inside. And you're all the time just, cycling and cycling against this. So when you have all this working pretty good, then you're able to just fix a bug, and in a matter of 15 minutes, have this bug fixed on production. But there is another problem here, and it's QA. And if you have a QA department, well, you cannot get it these 20 minutes to deploy to production. The reason it's a lot of things, but first thing is that usually organizations sees testing as an expensive task that slows down everything. So if you talk with managers, all of them say, yeah, developers are working pretty hard, they're writing tests, they're fixing bugs, but then it comes QA and all these manual tests, and everything goes pretty slow. But it's not only that they need to test everything. Usually, QA are just reviewing that the issues that the developer has fixed, they are really fixed, and they are reviewing manually. So they need to do end-to-end tests manually. They need to validate that the bugs are fixed. And even there is another problem, and it's that since we have a QA department, then devs says, OK, I'm going to write this code, and I'm not worried about the test, because I know there are some guys there doing manual tests, so I need to take care about this. They will do it for me. So it's even more and more work to be done for the QAs. So for this reason, QAs has a really expensive task. But it's even more. It's like, recently, when I've been talking with QA departments, they told me that they are not just doing end-to-end tests, they are not just validating bugs, but also they are in charge of maintaining the staging environments. So basically, it's like, OK, we have Amazon, which is pretty cool, or we have, I don't know, Azure, whatever, and then we have their build or staging environment and our production environment, and testing department are in charge of maintaining that the production environment or the staging environment are more or less the same as production environment. So they are in charge of checking that the staging environment has a network-like production, a database-like production, a configuration-like production. But notice that apart of this, so it means that you have your QA department and you are expending money on this department for doing something that it's not testing. Also, you are maintaining two environments which are fairly equal, so you are paying twice for the same. But even more, it doesn't matter, right? Because you have a staging, we have production, all our life has been done these kind of things. So you do all the manual tests, everything, you deploy to production, everyone is really happy, or not. Yeah, maybe this is an example, right, of failure on production. I mean that, firewalls are different, DNS are different, database schema is different. No. And many organizations use a staging environment as the only form of testing. And that's a problem. But what about a breakthrough idea? What if there is no end-to-end tests, no QA environment, no pre-production environment, just production environment? This means that production is not sacrosanct anymore. This requires a change in your mindset, appetite of risk, and changing how you develop code. No more staging, no more pre-production environments, just production environment. And one of the things that you need to think about it is that now deploy and release is something totally different. In the past, when you have a monolith application, deploy and release are used equally, in the same sense. So you're saying, I'm going to deploy to production, or I'm going to release to production. And for you, it's exactly the same, but it's not. One thing is deploy. Deploy means that you take your application, your service, and you put it on the cluster. You deploy it on the cluster, but you are not sending public traffic to it. Release is just when you switch to start sending public traffic to this new service. So if you have these two phases in a really different way, deploy and release, you are able to start testing on production, because you are using production cluster to test your services, but no one from outside the organization or outside the cluster will ever notice it. So please, stop applying old techniques to new contexts. Now we have microservices architecture. Stop doing the same testing techniques that you did in the past with a monolith. Think about microservices. Microservices allows you to develop and deploy at a scale independently, right? You can just take one service, deploy it, and the rest of the application is still running. So why are you doing something like, yes, but I'm going to test it in a different way. I'm going to spin up an identical environment. I'm going to deploy all the services there and see what's happening. Why are you testing everything together and not testing each of the components individually as you are deploying or you are scaling? And this means that all these kind of techniques that we are going to explain are not testing techniques per se, but something that in the past was in the release engineering process. And basically, probably everyone has read some days this pyramid, right? That which is like unit test, component test, end-to-end test on top, which usually it's the other way around, which is like a lot of end-to-end test, component test, unit test, but well, this is another history. But now in testing in production, it's something different, and I like to call it this new pyramid, where we have pre-production test, deploy test, release test, and post-release test, where all these three are testing in production tests. This pre-production test, which is the blue one, does not, yeah, now, well, it works. This one, okay, it's tests that are done by developers. So as developers, we need to take care of writing all these tests, and usually these tests are run on your Jenkins or your CI/CD system. So you run all these tests there, and when you hit green, you know that they are okay. When you have this okay, it's time to deploy. And as I said, deploy means put the service inside the cluster. And then you can start running all these tests: integration tests, tab compare, load test, shadowing, or config test. And we're going to see tab compare in this case. Notice one important thing is integration tests. Usually, people run integration tests, you know, in an isolated environment, right? I mean that yes, we have Docker, right? I can just do Docker run MySQL. I start a SQL database, and then I just run my test, and then I stop this Docker container. But notice that this is not really real test. I like to call it this as a snowflake test, because the database is empty. The network is that there is no network. It's localhost, so there is no network failures. It's pretty fast. It's empty. Everything will work for sure. But what's happening when you're going to production? The database is big, really big, with a huge amount of data. Probably the schema can be different than the one that you have started in Docker. And also, of course, I mean that all the configuration and there is some network outside there. So I really recommend you that you run integration tests against the testing, to production database. Then we have release. When you want to do the release, so that you start sending traffic to your running service, there is this canarying, dark canaries, monitoring, future flagging, exception tracking, and future graduation. You need to do this. You can do all these kind of tests. And then there is a post-release test. This is usually, if you think about in your test process, is that when you have released something, you do not test anymore. It's like, okay, it's tested. You have the seal. That's fine. It's on production. I'm not going to touch it anymore. But with testing in production, even when it's on production, you're still doing a lot of tests, like team profiling, logs, cause testing, monitoring, A/B testing, tracing, auditing, or journey tests, and so on. So even when you have your application running on production, you are still doing some tests there. Nothing of the things that I explained here are easy and often requires a fundamental change in the way that the systems are designed. You need to think about that now the test can fail on production. And this means that you need to implement some kind of patterns, like, for example, circuit breaker, to avoid problems when there is one service that is misbehaving. Let's see one technique, tab compare. Tab compare is a technique for that is run on deployment phase. And basically, it's used to detect regressions between services. So you have service A version 1, service A version 2, and you want to check if there is any regression. Any regression in terms of bugs. In terms of response, you want to compare if the response are equal or not, or in terms of performance, you want to check if you are behaving more performant in the new version or not. And this is one, it's called tab compare technique. There are like two tools. One is Diffie, and another one is Differentia. I'm going to explain you here Differentia. Differentia is implemented in Go. It's integrated with Java, and one of the great things about Differentia is that it's Kubernetes friendly, and it integrates with Prometheus. This means that you can just run Differentia inside your Kubernetes cluster with all the services, and the results are sent to Prometheus. This means that you can just use your public traffic, comparing the public traffic from the deployed version and the production or released version, compare, and the conversion is sent to Prometheus. So in your dashboard, you can just see if the new version is behaving correctly or not. And basically it uses something like this. I mean, that it gets different checks as a proxy. You have the service AB1, service AB2. I'm getting a request, and I send both requests to both services. Then I get the response, and then I have this some kind of comparison in terms of outputs, or comparison in terms of performance, and then I send the result to Prometheus, to a REST API, and also to a file. Of course, there are some things that you need to take into consideration when you are into to tab compare, and it's that sometimes the output is not equally. For example, timestamps, right? The timestamps are usually different. In this case, there are one algorithm which is called noise detection, which sends a request to 3 versions, which 2 of them are the same version. If they are the same version, we are able to detect noise and remove this noise from the other version, and you can compare it correctly. And this is an advanced topic, but yeah, it's nice to have it. Another thing, this is release technique, blue-green deployments. Probably everyone here knows what is a blue-green deployment, but basically it's that I have my blue service, I have my build, and I have my green environment, which now it's not receiving any traffic. Notice that the arrows goes to the blue, and then I deploy it to production, I run my integration test, my tab compare test, and so on, and then I put it to the green, so my service now it's on green, and I just switch the router from the blue to the green. And now all the traffic has been redirected from the old version to the new version. But one of the biggest problems with this technique is that if there is an error, there is a regression on this new version, all your users will get this problem, right? So you will need to switch back quickly, but during these 4 or 5 seconds, every user will receive some errors. Because of this, it was created this, basically if there is an error, what's happening? Now, if there is an error, you just need to switch back from the green to the blue. And since you have not undeployed anything, you can switch really quickly. Notice that this is also something that has changed. Before, when you were releasing a new version, you were undeploying the former version. But now, you are just maintaining both versions all the time on production. To avoid this problem of all your users receiving an error, you've got this canary release technique. Probably everyone knows what is a canary release. The important thing is that canary release is not something new. It comes from this. Well, it does not work. I see now. Now. It's this one. Okay. This is from the coal mining, which they use this canary to detect poison gases. And if the canary dies, then it means that there were poison gases and they need to run out from the mining as soon as possible. We're going to do exactly the same approach of this, having this canary, of course, not a real canary, obviously. I mean, when I explained this slide, I imagined some people going to buy a canary and put it on the server. Yeah, I don't know why, but I always think exactly the same. No, I mean, it's a digital canary if you want, which basically means that I have my blue service and I have this yellow bullet, which is the new version, and I put this on production, and I start sending traffic. But not all traffic. I start, for example, with 1% of the traffic. I start monitoring this new version, and if it behaves correctly, then I start to increasing the traffic that I'm sending there. 10%, 15%, 50%, and so on, until all the traffic goes to this new version. Of course, this works really well. I know a lot of companies here in Barcelona that are doing canary releasing, but they have, again, one problem. I said that you start with 1% of the traffic. But, OK, if you are a small company, that's fine. But what's happening if you are Facebook or Amazon, that you're receiving thousands of requests per second? For that reason, Google, Amazon, Facebook, they created, or they coined the concept of dark launches. Dark launches is an umbrella of several techniques which basically focus on testing on production without the end user noticing it. There are a lot of possibilities. One is, for example, doing dark canaries. Dark canaries is one technique which is like canary releasing, but in a way that you are not sending for percentage, but for some kind of properties. For example, you're saying, if the user comes with this range of IP, then I send it to the new version, and if not, I send it to the old version. So you can, if you are, for example, you're, as a company, using your own tool, then you can just say, OK, I know that my IP is this one, so I'm going to make my employees test my next release. Or, for example, you can do it by host. If you detect that a user registered with certain email domain comes from, I don't know, Facebook, then you send it to one service, and if not, then go to another service. So you're able to speak with other companies and have an arrangement to test them the latest versions. The other one with this technique we used in Red Hat a lot of times is shadowing traffic. Shadowing traffic is like sending a request, and then this request is sent to the both versions, the V1 and the V2. But notice the difference. In the blue one, the arrow is bidirectional. It means that I'm sending the request, and then the response is sent back to the user. But the green one, which is the newest version, is just a fire and forget request. It means that I send the request, but I don't care about the response. And why this is important? Because now I can monitor the green service and check if it works as expected or not. But notice that if there is some bugs, the end user will never notice this problem. So this is a really good technique to detect without the end user knowing it, that you are behaving correctly or not. So effectively, what you are doing is making that your customers, your clients, are the QA department, right? So this is really interesting, because now QA departments can start doing other kind of things. Another option is future graduation, or another technique that we are using in Red Hat. This is one product, Red Hat. Well, now it's called Code Ready, but the past was OpenShift.io, and we have something like this. The user have a settings, and they can configure the degree of confidence with our services. So each of our services are deployed with 4 different versions: internal experiment features, experimental features, beta features, and production-only feature. So then user choose which version want to test. And if they choose, for example, experimental features, then all the requests are sent to all the services that are labeled with beta features. So now our customers, our clients, are testing our application. And to implement this, it's really easy. You just need to create some kind of header. And this header you are routing based on a regular expression. So what I'm saying here is like, if the user preference is 1, 2, and anything, it goes to the beta, and it goes to, if it has a user preference 1, 2, 3, and anything, it goes to service v3, and if it's empty, of course, goes to production. So what's happened when there is a promotion? It means that the experimental becomes beta, because this is going to happen someday. Then it doesn't matter, because remember that I said 1, 2, or anything. So this means that both experimental and beta levels are going to match this regular expression. So any user that has configured 1, 2, 3, since 1, 2, 3 is 1, 2, and anything, it will go to the beta if there is no experimental. So in this way, we are promoting our services and promoting our users. Chaos engineering is something that a lot of people, I'm sure, that is doing now. And probably they are doing because Netflix is doing it, right? Because we are experts on doing this. If Netflix is doing, I'm going to do it as well. The problem with chaos engineering, well, is this. I remember talking with one company here in Barcelona. They said, hey, you know, we are doing chaos engineering. Oh, really? And what is your experience? Oh, really bad. Yeah? And I said, yes. And why? I said, because our first test was to shut down all the production environment. Really? Yeah. And what's happening? Oh, it was a disaster. No client could access to production environment. And for me, it was like, I didn't know if that you shut down all your production servers, nobody could be able to reach you. I mean that, you know, and this happens because they read somewhere that Netflix is doing, killing all a region. And that's fine. The problem is that instead of copying what Netflix does, first of all, you need to learn how to do it and then do it. Because chaos engineering is something really, really hard. Although the concept is really simple, doing it correctly is really hard. Of course, a post-release technique is observability. You need to all the time monitor what's happening in all your cluster. Each of your service, you need to get all the information possible to detect any error. In this sense, for example, Prometheus and Grafana works really, really well. Notice that in this case, I have an important app, say global success rate. So you can put here both versions, the version V1 and the version V2, and you are comparing the success rate. If the success rate is equally, then it means that your new service is behaving more or less equally, so you can start, for example, doing a canary release. But if not, if you say an increase of error rates, then it means that your new version is not correct, and you need to undeploy it and fix all the problems. Of course, Jigger, for example, also for tracing, you need to know what's happening inside your cluster all the time. So Jigger, what allows you is to, for each request, how it's behaving inside your cluster. So you can see your request across all the services and what is the time that it's spending in each of the services. So let's see a demo of some of the concepts that I explained here. Basically, I'm using Istio. I don't know if you know what is Istio, but if not, I recommend you that you check what it is, because it changes how you can release and deploy your applications. I've got here an example running. And basically, I have here my thing that... OK, I have here my microservices architecture, really simple, which I have customer, preference v1, recommendation v1, recommendation v2. And now I can just go here and just run Istio to do a release. First of all, I need to First of all, I need to register recommendation. Remember that I have recommendation v1 and recommendation v2, and I want to register this service saying, hey, Istio, there is a recommendation v1 and recommendation v2. And, well, apart from other things, but yeah, you can do this. Now, I'm going to send all my traffic. So I'm going to release the version v1. And this is done by just doing create-f, Istio files, virtual service, v1. Now, all my traffic goes to recommendation v1. And you can see it because if I do a call, you see that all the time I'm going to customer preference recommendation v1, recommend v1. Now I want to do a blue-green. So I want to switch from v1 to v2. See that see now that I have recommendation v1 released and recommendation v2 deployed. It's on production. So now the service is there, and I could run test against it. If I want to just release, I can do a istio-ctl replace, and it's just a matter of applying another resource. This is a Kubernetes custom resource. And I do a call, and now all the time goes to v2. Just with, I have not redeployed anything. I'm just sending a file, an Istio resource, and it just works. Of course, I can do istio-ctl replace to v1. And now, if I do the call, again, all the time goes to v1, v1. How I can do a mirroring traffic? It's really easy. Notice that these numbers, OK, is a counter that every request that it reaches the service, it's incremented. So notice that v2 is the number 3, and the v1 is number 6. Now I can, here, I'm going inside. Notice that since I'm in Istio, I have two containers running, the Istio proxy and my recommendation v2. And now I'm going inside. Currently, I'm inside the container. And I don't need, well, actually, I don't need this. What I need is the logs. OK, notice that now recommendation v2 is in the number 3. That's fine. I'm going to here, and I'm going to istio-ctl replace the files. And I'm going to start mirroring the traffic from V1 to V2, which is a rule somewhere. It's here. OK, now I'm sending traffic to V1 and V2. I'm just taking care of the V1 response, and I'm just ignoring the response from V2. But the request is sent to V2 as well. How I can see this? Notice, this is the number 3. OK, here I'm doing a call. I'm getting V1. I do a call. I'm getting V1. Get a call. Getting V1. And see the logs. There is 4, 5, and 6. So the traffic is sent to V2 as well. So now, this is a really simple example, right? But if you think about in a complex scenario, you can just use the public traffic to test V2, how it's behaving, because the requests are also sent to there. So if you want to learn more, there is this tutorial in Istio tutorial, which I think that is the greatest tutorial out there about Istio. It's done, well, we've done in Red Hat, and you find this example, how to use Istio with feature graduation, with dark canaries, dark launches. You also find how to run integration tests against production, and so on. So everything is there. And of course, when you're thinking about testing in production, it's like, OK, how can I start working on this? The first thing is that Devs, Ops, and QA need to work together from the beginning. If not, these things are not going to work. From the beginning, it's not development or testing is not a post phase of development. Development is also testing. And the same for Ops. Releasing and deploying is not something done after the test, but it's done within the test. How to implement this on your organization? The first thing is that do not try a big bang effort. Not everyone is going to do testing in production. No, because this is not going to work. The first thing that you need to do is find the innovators. Basically, you need to, this is more or less on every organization how people are, and find the innovators. Find these groups and talk with them and say, look, we're going to do some kind of testing on production. And try it, and do it. And probably you will fail at first, of course, but you will learn and you will start increasing your levels of credibility, influence, and support from the organization. Then you will get some critical mass, and you will have some enough, and you will start having some enough success to tackle all the holdouts that you can find it. You will jump the chasm and start early majority, late majority. And finally, just remember that there are always 16% of laggards. That basically, these laggards, it's like these people that always blame about everything, right? I always said that I'm really sure that when the humans discovered the wheel, there were 16% of the people that said, the wheel isn't a stupid idea. It's better to bring everything and move it from place to place and not putting on a wheel, right? I'm sure 16% of people are still doing this. So no worries about these 16%. They exist and they will be there. No, it doesn't matter what they think. But what's happened with the QAs? But a lot of QAs tell me, and now what I'm going to do? Well, the first thing is evangelism. They need to evangelize all the development teams that they need to do this, and teach them how to do it, and of course also doing some kind of pull request review. And I'm not saying about the business code, but about the tests. So they need to teach the developers how to write tests, validate that the tests are written and they are written correctly. It's a bridge to the management. They need to check with the managers and talk about what we are going to do, the risks, and so on. They need to define strategies. Of course, of all these columns that I've showed you there, you don't need to use one strategy, and that's all. I mean that, for example, in our case, we are using shadowing traffic and canary releases. We concatenating both ideas, right? So probably they need, for each case, for each group, for each service, they need to find a cool strategy for releasing this way. Also write tests, but of course no manual tests and no maintenance tasks. Let's wind down. The first wall is that the wall is full of temptations, right? Now developers can say, oh, we have our customers that are testing our production, so I'm not going to write any tests. Because there are, we have some techniques to detect this, so don't do that, okay? Tests are there to be written. This is not a substitute of tests, it's just a way to release faster. Go step by step, and you'll be able to release every day, right? And you will see that it's really worth to do this testing in production, because you're going to be able to release every 15 minutes and not every 3 months. But of course, when you get it this level, you get it to, releasing every 15 minutes, don't stop here. Just start, continue thinking how you can improve, and more improve, and how you can change to be better and better. And that's all. That's my Twitter, my YouTube channel, my mail, and my blog. Of course, you can send me an email, because some people ask me, can I send you an email? And it's like, of course, it's here, the mail. If not, I will not put it on the slide. So feel free to send an email. Thank you very much.
Questions?
I will be around here now, so that maybe it's easy to approach me privately, but as you wish.
I think there is one. There's one.
One?
Yeah, it's coming.
Vale.
Hey, can you hear me? Yeah. So congrats for the talk. It was really interesting. I wanted to ask you, if you have integration tests in your production environment, how you make sure that the data that your integration test is putting on the database is not being merged with the data, the real data that you have? Thank you.
Yeah, this is some risk thing that that you're running your tests, your selects, your inserts against the production database. Yeah, that's fine. That you just need to follow the same rules that any other user runs, right? I know that there is some kind of problems with the deletes and so on, and I'd like to explain you one thing is like let's say it. Well, wait. Basically, because I've seen that I pushed. Now, is anyone want the mail? Basically, there was a company in Germany that they were doing wash machines, right? And they were selling online, and they started running tests on production. And one day, they're working all the developers, and they arrived 3 lorries with 300 wash machines. Basically, what they did was running tests on production, and they didn't mock the payment gateway. So the test probably was like, I'm going to buy 300 wash machines, and then, of course, the 300 wash machines arrive at their offices. So I know that it's a risk, right? And these things can happen. Yeah. But remember this. How much money are you spending on a staging environment on Amazon, on Azure, or any other cloud? And if you don't have this environment there running, how much money you will save? And then you just need to balance if it's worth to try testing in production, and probably the first year you're going to spend the same money as before because of this kind of errors, right? But the next year you will start saving some money. So yes, that you need to run it on the production environment, and of course there is some risk, but I think that, at the end we are doing it in this way.
Thank you.
Sorry? Yeah, at least they say that at least you have the washing machines with this money. Yeah, true. Well, probably, yeah. But that probably it was like, okay, there has been an error. They just pack again the wash machines, and yeah. But this happens. You can. I cannot remember. Yeah, I think that it was Dell, like 2 weeks ago. Yeah, 2 weeks ago, that they would start selling computers for $39 or something like that. Yeah? Testing in production.
Okay, guys.
Okay.
Oh, no more questions? Okay, so enjoy the break and see you later for the final two talks. Thank you, Alex.
Thank you.